Large Hadron Collider is an international research project based at CERN in Geneva, Switzerland, where scientists and engineers from 111 nations are taking part in one of the world's largest scientific experiments ever conducted. In the UK alone, engineers and scientists at 20 different research sites were involved in designing and building equipment and will soon be analysing data from the detectors. Yet recently, when the LHC was switched on to find out more about the universe and how it works, there was huge media hysteria about black holes being created that could potentially cause the end of the world. The general public were aware of the existence of the LHC and had some vague idea about what it was, but they didn't know what it did, hence the gross misconception that the world might end. The aim of this mini-documentary is to hopefully clear that misconception up a bit. So, how to start? With over 6.5 billion people in the world and about 7 million in Greater London alone, our best course of action was to ask some of these decent hard-working folks their opinions.
Not at all. My feeling is that there's first of all little interest for what's going on in physics. Sometimes there's a little bit more popularity in the media, like LHC startup and so on, but the public has very little knowledge of actually what's going on, and what is much more worrying is very little understanding of how science actually works.
People working in the media for science have a difficult job because they need to try and encapsulate some very difficult research that's been done by hundreds, and in this case thousands of people, into a package that they can deliver to people.
Money well spent. What do you think we'll get back from it?
I think it was probably money well spent, but not in the short term. I mean, considering it broke down a week later, definitely not in the short term.
LHC.
I think it's about as valuable as this pineapple here.
So
both delicious, but prickly and dangerous.
It's a lot of money into something that hasn't given a result yet. So, like, from the public's point of view, it's not very good. But
yeah, you never really know what's going to come out of it until you spend the money on it. So I think it was probably worth it because we'll get supercomputers and armies of nanobots due to this amazing spending of money.
Were you concerned about the world ending due to black holes being created at the LHC?
No, not after Stephen Hawking said that apparently such black holes were created every day in the upper atmosphere anyway, so it didn't really bother me.
So do you think the public were genuinely concerned about black holes being created? Yeah?
Yes.
Did you think the world was going to end in September?
I did, because I was working as a newspaper boy, and it said it. World ends at 7:43 or something.
A staggering 75% of people correctly recognised a photograph of the LHC, and more than 80% had heard of it and had some idea of what it did. Unfortunately, 15% of people surveyed were genuinely concerned that the world would end by being swallowed by a black hole. In order to understand more about how people pick up on the news, we invented 3 news articles about the LHC. These were supposedly featured in the Times, The Sun, and the Daily Mail. 60% of people chose the article attributed to the Times over the one supposedly from the Sun and the Daily Mail. Even though we stated that all 3 articles were made up, people had the tendency to believe the Times article without even reading it, purely because of where it was from. People assumed that because the article was from the Times, it was well researched and was therefore much more likely to be true. This just emphasizes the importance of media accuracy when it comes to potentially contentious scientific issues, such as the hypothetical end of the world.
So, in order to understand why the world is not going to end, it is first important to understand how the LHC works. Let's start from the beginning. Hydrogen gas atoms are pumped into the source chamber of the linear accelerator named LINAC 2. Hydrogen is the simplest element, consisting of just one proton and one electron. Therefore, when it is ionized, the electron is removed, and we are left with just a proton. These protons have a positive charge and can be accelerated by an electric field. LINEC 2 accelerates the protons to 50 megaelectronvolts. At this energy, the protons are traveling at 1/3 the speed of light. However, with such high speeds, linear acceleration becomes impractical, so circular acceleration is used instead. The proton synchrotron booster consists of 4 rings, each with a 150 meter circumference. These boosters accelerate the protons to 1.4 gigaelectronvolts before it injects the particles into the proton synchrotron. This 628 meter ring accelerates the particles to 28 gigaelectronvolts. At this energy, the particles are traveling at 99.9% the speed of light. Because the particles can never travel faster than the speed of light, they will instead start to increase in mass. The particles now enter the superproton synchrotron. This is the penultimate stage in the particle's acceleration. This 6.9 kilometer ring accelerates the particles to 400 gigaelectronvolts. At this energy, the particles are ready to enter the 27 kilometer ring of the LHC. The superproton synchrotron fires protons in both directions into the LHC. This is the final stage of the acceleration. Each proton now has an energy of 7 tera-electronvolts and are ready to be collided. The beams of protons cross at 4 controlled points. Each of these points has a different detector: Atlas, Alice, CMS, and LHCb, all built to detect different things. Let's now have a closer look inside the detector. Millions of protons, all travelling at 99.99999% the speed of light, go through the detector every second. These protons will have already travelled round the LHC tens of thousands of times, before eventually colliding with a proton travelling in the opposite direction, resulting in a collision replicating the early stages of the Big Bang. It is in these collisions that people have speculated the creations of black holes.
But what actually is a black hole? When an object, like a star, can't withstand the compressing force of its own gravity, it turns into a black hole. This is something that has such a large mass in such an incredibly small volume that its gravitational force is strong enough to prevent light, or anything else for that matter, from escaping. Many objects, including the Earth and the Sun, won't ever become black holes, since their gravity isn't big enough to overpower the atomic and nuclear forces holding them together. The mass of the black hole is proportional to the size of the event horizon, which is also called the Schwarzschild radius. This is an imaginary sphere that measures how close to the singularity you can safely get, but once you have passed it, it is impossible to escape. Anything that enters it will be drawn in by the black hole's gravitational pull and squashed into the singularity. This is a point within the center of the black hole where all matter is squeezed into a region of infinitely small volume. If the LHC were to create a black hole, and this is a big if, it would in no way be on the scale of the one seen in the universe. In fact, it would be microscopic, invisible to the human eye and causing no effects that we'd even notice in day-to-day life. Theoretically, it would happen during the collision of a pair of protons. Each of these collisions releases an amount of energy equal to that of 2 colliding mosquitoes, and since black holes observed in the universe have huge masses considerably bigger than the Sun, and the collisions at the LHC only result in a mass that's far smaller than this, any black hole produced would be much smaller than any of those known to astrophysicists.
The whole community around CERN in particle physics knows what's about these mini black holes, that we don't necessarily agree on whether they are going to be produced or not. It depends on the energy, it depends on a lot of things. But we know they're unstable, we know that they can't harm. But then, of course, black holes, just the word sounds frightening, and then people jump on that and make some end-of-the-world theories.
In reality, particle collisions happen every day just naturally, and we're all still here. What the LHC aims to do is no different from this, except it's being controlled in a big underground chamber in Switzerland. It has the potential to answer a whole variety of questions about the beginning and the nature of the universe, and instead of being frightened by the media into thinking of this badly, we should be celebrating the opportunity for the discovery of lots of new and interesting things.